I have used the word quadratic function or quadratic equation interchangeably, but here is the difference between them. If you want to be mathematically correct, equation on the left hand side, you will see that it has equals 0. So the form, the math expression is set to be equal 0. We call it equation. Quadratic function is when we have the f of x equal and it's not set to be equal 0. And that's the main difference, I think. But you can use it interchangeably. Next, let's make sure that we can say a few words here. Let's say quadratic. Very good. Next, properties of exponents. Good. Parabola. Parabola, which is the graph for the quadratic functions. And then vertex. Vertex is the points on the bottom right here of the parabola. We also call it the minimum point because it's the lowest point of the parabola. If it's upside down, then it's become the maximum point because it's the highest point. Next word, expanded form or exponential form. Good. A couple more things on the graph. When we get to the graph part, this will be explained. We have the root, and the root are the x-intercept point. We also have different name for the roots. We call it the solution, the zero of the function, and so on. And then you also see the pink line, which my bubble is hiding it. So I'm going to move it slightly to the left here. The axis of symmetry is the place where we fold the parabola and it will be exactly the same on the other side. We call it axis of symmetry. Here again, the vertex point is displayed in the red point. Down here, we call it one minimum point. Axis of symmetry. Make sure that you can say that as well. Objective: students expand exponential expression into repeated multiplication. In order to simplify them, student can use rule of exponent to simplify algebraic expressions. And student will formalize and use the law of exponent to solve problems. Why and where do we need exponents? Well, numbers with power can look complicated, but we can use exponent rules for an easier calculations. There are so many fields that you can use the rule of exponents, and this is one of the reasons why your notebook, the cover one, is showing you the universe. It's because it's like you have the rule of exponent down, you get the rule of the universe in your hand, and so many things can be calculated, like the distance around the moon, the distance from Earth to the sun, or other places. And I'm going to go ahead and show you more. On this website I found Math is Fun, quadratic equations, and you can see the yellow word right here said this make it quadratic because of the square on the x. So when it's a 1 or invisible, there's no power, it's invisible 1, we call it linear function, right? When it's square, we call it quadratic now. So quadratic equation make nice curve. You can see the athlete there, and of course sport players or athletes. If you want to be really good at what you do, you have to study the path of the parabola, the path where your ball is going to be when you throw it, right? Basketball, or when you kicked it like soccer. Right here, we also have the name right here. So the name quadratic comes from quad, meaning square, because the variable gets squared, like x squared. It also called an equation of degree because of the 2 on the x. It is standard form, and we will go ahead and learn about standard form, vertex form later part. Okay, so the standard form is ax squared plus bx plus c equals 0. Remember, standard form is going to be equal 0. So we will go ahead and explore that much later on. Standard form, vertex form. In this lesson, I want to go over the properties of exponents, and you are seeing this beautiful notebook, but it is still in the work, and the part about exponents are done. Let's start with, here goes, all about exponent and its related work. Table of contents for you. We start out with classifying the properties of exponent, and my favorite way of saying it is rule of exponent, or abbreviated with RoE. Now, we are going to build on the rule of exponents and do quite a lot of things, okay? First of all, we have classifying. We want you to make sure that you can recognize the properties of exponent, each properties. And then we also want to use the property of exponent to distribute, to multiply, monomial, binomial, trinomial, polynomial, add and subtract, multiply, divide, graph, the quadratic function, because that's what we have when we have exponents on the variable. Building on that, we're going to go further with factoring, and it's getting a little bit more challenging with solving quadratic equation as well. Factoring and solving quadratic equations are the step up from just learning the property of exponents and using the properties of exponents, okay? I have a quote right here. You are confined only by the walls you build yourself. Let's move on. Classify. We have two ways of naming the expression, algebra expression with variables and numbers mixed in there. We have the terms, and we have mono, the prefix mean one, right? Monomial. Prefix mean two, binomial, tri for three, trinomial, three terms, poly, many, like more than one, like the binomial, we can also say polynomial. Like the trinomial, three terms, we can also say polynomial. As long as it's more than one term, we just call it polynomial to include anything more than one term. And then by the degree, you also have heard of the word constant before. Constant is a number. Linear function, which is a straight line. Quadratic equations that give you the parabola. Cubic function and quartic function and quintic function. But those two last named with starting with the Q are not very popular. We will not focus our energy on those two. Okay, exponent rules. Remember, we call it many different names: properties of exponent, exponent properties, rule of exponent, exponent rules. Okay, now you can see another name: laws of exponent. There are actually 7 of them, but we're going to shorten it all the way down to 5, the main 5. So the first one is product rule. You see right here in blue. The product rule just say that you add the exponent. Quotient rule number 2. You are subtracting the exponent. The power rule, or I usually like to say power on power. That's where you multiply the little exponents when we have the same basis. Okay, now when we have the same basis for all of the first 3 rules right there, that is required. The 4th rule is the zero power rule. Anything to the 0 power equal 1. So x to the 0 equal 1. 7 to the 0 power equal 1. I have negative 5 inside the parenthesis to the 0 power is equal 1. Okay. And the last one, which is I think is fun, but it might be a little bit challenging for some people, is called negative exponent rule or negative power rule. To use the exact word in here. And with the negative exponents, we can never leave a negative exponent in the answers. We always have to change it to positive. The way that you do it is just flip it over. If it's on top, it go on the bottom, it has a positive exponent. If it's negative exponent on the bottom, flip it and put it on the top, and it will turn into positive exponent. That's all you have to do. It's fun, but it can be a little bit challenging for some people, right? What order should I simplify in? There's like 5 or 7, exponents, properties there. What order? First, you see 0 exponent. Go ahead and do that first. Okay. If you see negative exponent, turn it into positive. Number 3, parentheses. Okay, simplify, take off, eliminate the parentheses. Numerators, you worked out the one on the top of the fraction bar first, and then the denominator, which is the bottom part, you simplify that, and then you divide if you can. Numerator multiplication with the same basis. Okay, so you can see some example we give you in there. Always when you have a something with a fraction, top part gets simplified, bottom simplified, and then we finally see if we can do anything with the top and the bottom and see if we can divide or simplify further there. Next one, number 6, divisions with the same base. If you have the division, we call it quotient rule before, or quotient property. You are going to subtract the exponent when we have the same base. Number 7, negative exponent. Again, if we have negative exponent, always change it into positive exponent unless the question say leave your answer with negative exponents. Then and only then can you have negative exponent in the answers. And finally, number 8, reduce coefficients. Like the example in here, we have 2 over 18. We can reduce or simplify by dividing both 2 and 18 by 2. We got to make sure that it's going into the simplest term. Okay, remember, you may only use these exponents rule with like bases. Power to power, multiply or the product rule, and then also the quotients rule. If you look on the bottom part of this page right here, we have some fun matching activity. Google Slide, you can go ahead and complete that during the classwork. And don't forget to check your answer and make sure that we're on the right track. Answer check for the first one that we asked you guys to practice on when we started with the exponents, product, and quotient rule only. Extra practice, mostly on this page though, is practice with the negative exponent. Distributive, multiply or divide. Okay, first we are multiplying monomial, which is one term, with the one in the parenthesis, with the binomial, 2 terms. And some of the problem, like starting with number 9, 10, 11, and 12, we have one term monomial, multiply trinomial, which is 3 terms. Multiply binomial. Binomial means 2 terms, 2 by 2. We're multiplying it. I'm going to go ahead and show you 3 different ways that we can multiply it. You need to know all of them, but you can just use your favorite method after you've learned all 3 methods of multiplying. And then multiply trinomial and polynomial. Add and subtract polynomial. This one is easy. We will do some practice together. All you have to keep in mind is the like terms in adding and subtracting polynomial. We only add, we only subtract when we have like terms. What are like terms? Remember the flashcard. Make sure to pull out your flashcard on like terms and review. Like terms are terms that have the same letter, x and x, not x and y, right? And the same power. Power is the exponent. So same letter, same exponent. Graphing with quadratic function. Graphing is fun. I have some video questions on graphing that I'm going to show you with this one. We also have the graphing with the t-chart or the xy chart. Same thing that we have always done before. X are picked for you, and if it's not picked, you just pick yourself some easy number. If it's already pre-picked, like the first one, number 1, then go ahead and just substitute that X and find the answer for Y, and then we plot each point. And always when you are graphing the quadratic function, which are these functions that you see, you're going to get parabola like this, open up or open down. And in number 2 and number 3 on the t-chart, you don't see the number picked for the x, right? Write it in. -2, -1, 0, 1, 2, 3. Okay, pick easy number like those. Just write in the x, substitute the x into the function for y, and find out what the y would be when you square the x plus the x and then -2. Now find what the y is going to be. Plug it in. Get x squared minus 2 times x minus 8 and plot your points. It's that easy. This one is on factoring and solving quadratic equation. I will save that for another lesson. And just for those who might have forgotten what base and what exponent is, we are going to go ahead and show you what that is right here. Starting with exponents. Exponents show repeated multiplications. Exponent represent how many times a number base is multiplied by itself, and it is indicated by the exponent, how many times it should multiply itself. So the base is always the big number or the big letter. Okay, base big, B, B. Like the number 5 to the third exponent right here, we have base, the 5. And then the exponent is the small little one, and you always want to make it smaller than the base, always. Okay, and it's going to be on the top level. So the 3, we call it 5 cubed or 5 to the third power. Or the exponent is telling you 5 multiplied by 3. Okay, 5 cubed is 3 times. And then your answers, if we ask for the simplest answers, we're taking 5 times 5 times 5, we get 125. And then the exponent form we show you in the blue box. Just down here, exponent form, the word form is 2 to the 4th power. That's how we say it. And then the expanded, remember expanded is something we make it longer. That's where we get the 2 and multiply 2 times 2 times 2, 4 times. Okay? Because of the exponent 4, we write it 4 times. And then the standard form is where we write the simplest answer, where we multiply it out and we get the final answer, 16. Any number raised to the first power is itself. So remember that. Any number raised to the 0 power is always 1. And that's one of the property that we went over earlier. We have 5 rows on the left. And it said 5 rows, skip the parentheses rows. I'm going to point out exactly which one we skip on the right hand side. We have 7 rules of exponent. First off, we start off with the word on the top. It said, when in doubt, write it out. Always in math. The product rules, we add the exponent. So that's rule number 1. Rule number 2, the quotients rule, where we subtract the exponent. Rule number 3, the one that we get switched with number 2 sometime. This is the power on power. Remember the power rule. Multiply the little exponent. 0 exponent rule. Always, it's always equal 1. And then finally, but my favorite one, negative exponent rules. When it's on the bottom, we flipped it and make it go on the top. When it's on the top, we flipped it and we make it go on the bottom, and it will turn positive. Now, the 2 rules that we skip from the 7 rule here. The first one is this one, and you can see it has to do with the parenthesis. When you have the little m, the exponent m, we are outside of the parenthesis. We're going to apply it on both of the a and the b, and we end up with a to the m power, b to the m power. Same thing with the fraction we have right here. When you have a little m for the exponent, you're going to apply it on the a and also again on the b. We are going to end up with a to the m power, b to the m power. So both of them have to do with the parenthesis. The exponent on the outside of the parenthesis apply to everything, and I mean everything inside the parentheses. These are the 2 exponent rule that we skip when we mention 5 rules of exponent instead of 7 rules of exponent. We skip those 2 because everything's on the outside apply to everything inside the parenthesis, and that's something that we've learned, we've known way before, and it makes sense, right? So that's why we feel like we can skip those 2. On this classwork with the rule of exponent, the name is match it, just to match the name of the exponent rule that you would use to solve it. But remember, we're not asking you to solve, but we're grabbing the rule of exponent, the one on the left, and put it onto the boxes, red and blue boxes that we have right here. Number 1 has been done for you. If you have this in the present mode, you will not be able to graph the one from the left. Number one is done for you. First one is negative rule of exponent because we have negative 5 power and negative 4 power. So I know that I would have to simplify this first by changing it to positive. Number two also have the exponent rule. So what I would do is I would graph this negative exponent rule and put it right here in this box. But also I noticed that the m and the m to the 5th power and m to the negative 8 power, I can actually combine them by doing the product rule, adding the exponent, or I can use the quotient rule, especially if you apply the negative exponent rule first. The m to the 8 power go to the bottom, right? So now you can use the quotient rule. And so here I'm going to also have quotient rule applied onto here. You can see one box can have more than one answers, right? It did not require that you only can have one answers. So more than one can be possible for some of the boxes. And then on the second slide, we're not asking you to do anything. It's just the cutout for convenience. If you want to use it on flashcard, on your notes, or just to play around with, you can go ahead and print that one out. There's no work to be done on this slide. Here we are on to my favorite part, the practice, the get to use the properties of exponents. And you are seeing several different worksheets, and we layered on top of each other for you. So starting with the one on the right hand side, which is right under my bubble right here. You see this one first because we asked you to practice with the product and the quotient rule first to start off. And we don't scare you with all 5 or all 7 of them. The first one, we are using the product rule. Remember, product rule is where I am adding the exponent and I'm keeping the base. Okay, so 4 is the base. The exponent 3 and 9 added, and I will get 12.
Just one thing to keep in mind, Ms. Nong is not asking you to get 4 times 4 times 4 12 times and get the biggest answers for the simplest answers. We are going to be happy with this one if you leave it like this.
And if you are asked to simplify later on, you're going to get the final answers, which is what is 4 times 4 times 4 12 times. The section number 2 use the quotient rule, and the quotient rule, you will remember, we keep the same base, but we're doing the opposite. Instead of adding the exponent on the product rule, we're subtracting the exponent. So 8 on the top exponent, subtract the one on the bottom exponent. 8 minus 3 in that order, and the answer is 5. The middle worksheets or practice problem that we have right here, we have various rules, and it said complete each question. You will notice that we have a to the n power, and there's a fraction bar a to the 7 power equal a to the 2nd power. So what would be the letter n right there? So what is the letter n that would, when I subtract the n minus 7, I get 2. Ooh, that would be 9, right? N is equal to 9. There. When we have the quotient, remember we take the top exponent, we subtract the one on the bottom in that order, and then we get a to the 2nd power. And so the n power there gotta be 9. 9 minus 7 equal 2. So answer the question that we asked you on this paper. Number 2, we have 12x to the 5th power on the top, on the bottom, 4x equal 3x to what power? N. So again, we're looking for the letter n. 4 divided into 12, I get 3. That makes sense for the answers. And then x, remember, 5, subtract the one exponent on the bottom when we have quotient rule. 5 minus no exponent on the bottom. That's a 1. Okay, invisible exponent 1. When we need it, we can put it in. So n is going to be 4. Our answer for that one is 3x to the 4th power. Okay? That's the middle part there. Now I'm going to, before I move on, let's pick something that is easy. Miss Nong loved this one. Anything to the 0 power is 1. Remember that properties of exponent? We have that one. Okay, the next one. The second part here, we're asking you to simplify, and that's what we're doing here on this part. I'm going to go ahead and change from negative exponent changing to positive exponent. It is on the top because there's no fraction, so I know I can put a 1 underneath. I cannot put the 1 on top, but I can always put a denominator 1 in. Now I'm going to make it positive by flipping it over. So I will get 1 over. So both of them become the denominator because it was on the top, the numerator before. I need to make this fraction a little bit longer. So 1 over r to the 5th b to the 4th power rule here. The second exponent, remember, we are applying it on the 4, which will get, we will get 4 squared, which is 16 at the end. The next step, we will write 16 in. And then remember too that we multiply the exponent when we have power on power, like 3 and 2 right there. What do I do? Multiply. 3 times 2 is 6. And my final answers, to simplify, you have to make sure that the 4 square get worked out. And we will get the final answer to be 4 times 4, which is 16. And then y to the 6th power stay the same. So in this one, on the left-hand side, practice problem here, we need the simplest answers. So we cannot leave the exponent or the power on the number at the end, like the right underneath my bubble, where we leave it with the exponent, 4 to the 12th power. So keep that in mind as we work through. Just pick some random problem to work out. Remember, anything to the 0 power equal 1. So this whole thing inside the parenthesis equal 1. And I just get 3 cubed, or 3 times 3 times 3, which is 27. Box it when it's the final answer one right underneath that one. R to the 5th power and then g to the negative 3rd power. Okay, negative exponent, change it to positive. So on the top, go on the bottom and it becomes positive. R, I'm not doing anything to R because there's nothing to simplify. We don't have the same base. Okay, but the g is going on the bottom. So g here, and then negative power become positive power. Power on power, we just multiply. So 3 times 6, 18. X to the 18 exponent. 3 over 9, we're dividing its number. So 3 and 9, I can divide by 3. And I will get 1 over 3.
3, I get 3. So 3 is going to be on the bottom. Remember to take the numbers on the bottom there.
Okay, x to the 5th minus x to the 1st power. With the same base, I can go ahead and subtract the exponent. So 5 minus 1, I get 4. So this is 1x to the 4th. And remember, 1 can be invisible. So here's my final answer. On this one, I get the problem straight from your ebook, 3-3. And it comes from CPM 3.1.1. Simplify each of the expression below. Start by expanding, which means we make it longer on the exponent, and then simplify your result. Look for patterns or possible shortcuts, which are properties of exponents, that will help you simplify more quickly. Be prepared to justify your patterns or shortcuts to the class. So first off, number A, or the letter A, first problem, we get y to the 5th times y to the 2nd power. So expanding it means that I'm making it longer. Y times y times y 5 times. And then we write y times y 2 times. And then we are going to get the answer. When we have the product rule, remember we're adding the power. So 5 plus 2, we get 7. Y to the 7 exponent. The letter B, you're going to do the same thing. W to the 5th power, W times W 5 times, and then W squared. So write it 2 times, and then we simplify. It's asking us to expand, and then we're going to simplify, and we must make a 1. Okay, W divide by W, or 7 divide 7, we get 1, have 3W left. Same thing on the letter C, we're expanding it first. So this expression for x squared raised to the 4th power, you can see we have x squared, we wrote it 4 times, and then we're going to be able to simplify using the product rule now by just adding the 2 plus 2 plus 2 plus 2, I get 8. Or if you use the power rule, remember you just multiply these two, power on power, we multiply those, and 4 times 2 is 8. We are going to go to the more complicated problem at this time. How do you feel like so far? I get excited when the problem get more difficult, and you know what? That's only with practice. Once you master rules or the properties of exponents, all 5 of them,
we are going to have the 0 exponent right here, which gives me 1. So I know that this is going to be 1 first of all.
And the negative exponent, we will go ahead and move it down. It can be positive. You can see y to the negative third power on the numerator become positive when we moved it down to the denominator. Now I'm going to go ahead and simplify this part where we have the exponent on the outside of the parentheses. So let's go ahead and see if we can simplify this part right here. The z squared is going to stay there. I'm going to go ahead and write negative 8, if I multiply it negative 8 by negative 8, I get 64, positive 64. So I'm going to go ahead and write that in. 8 times 8, 64. You can write it behind, or usually we have the number right here. We call it coefficient because it's always in the front. Negative 8 times negative 8, 64. And now the 2 is going to apply on all of these, x and y. The z square is staying there. We haven't done anything to it yet. And look at the y cube and the y square right here. I can use the product rule and I can add the exponent. So let's go and simplify there. The x part, if you look at x to the 4th on the top numerator and x squared on the bottom denominator, we can go ahead and use the quotient rule. Take 4, subtract 2, I get 2. So I'm left with x squared on the top. And I'm going to go ahead and write that in. Negative x squared, remember the negative is still there. We are going to end up with 32. Y to the 5th power.
And the x is eliminated from the denominator, so we only have the z. And it is z squared. There's nothing to be simplifying with the z. So here is my final answers. We can go ahead and box it.
Ta-da! We're done! Let's go ahead and have you guys practice on the other 3 problems on this page. It's time now to go ahead and practice problem. Post it in your Canvas class or your digital math notebook.